Hello, and this is the PR2 Robotic Hand and Syntouch Sensor Real-Time Interface Project for the CS426 Capstone course at the University of Nevada, Reno 2015-2016. The main goal of our program is to utilize the Willow's Garage manufactured PR2 robot along with the Syntouch biotech sensors to create a suite of tools which allow future researchers to quickly and easily perform their own robotic experiments. Here you can see Ada, our PR2 robot, and UNR's own Robot Research Lab. As you start our program, you are presented with several options of actions to perform, such as saving data to disk and opening a window of available actions. We will begin by opening up the Data Graphs pane. The Data Graphs pane, along with all other panes, is both resizable and undockable. Each of our graphs is capable of displaying any of the 10 available data streams coming from 5 separate sensors on each of the biotech fingertips. Each finger is able to detect force, temperature, thermal flux, microvibrations, and fluid pressure. The data graphs all automatically adjust to a visually appealing scale, as can be seen when we manually input external force on the fingertips. Both the force graph and the fluid pressure graphs are now showing spikes. Another feature that has been implemented is the ability to scale the data graphs along the x-axis of time. This can be achieved by simply typing a value into the provided box. As you can see, we now have the past 50 seconds of data shown in order to easily discern data trends. The Sensor Visualizer window shows the current value of each individual data sensor on each of the fingers. These bar graphs are automatically scaled over the lifetime of the program, with the lower bound being the lowest recorded data point and the upper bound being the highest recorded data point. Having this data readily available allows users to see how any given action affects the very precise measurements, such as breathing on the sensor or visually seeing the difference between room temperature and ice water. As our main idea of the project was the collection of data, we have also implemented a lifetime data statistics window. This window shows the average data rate from the fingertips, along with how many data ticks have been received since the program has started, along with the most performed action and how many actions have been performed. These actions are found under the submenu Run Program and contain the pane of buttons to perform several given tasks. Several of these actions include Close Hand, which closes the PR2's robotic gripper, along with Open Hand, which opens the PR2's robotic gripper. However, these are static commands which do not use the Syntouch fingers. Here we can see our Grasp Objects subpane, which handles grasping objects of different size, shape, and strength. Once the user inputs an optional value for the strength of the grip, the PR2 uses a tactile feedback loop in order to gently but firmly grasp any object between its grippers. Next, after we grasp the object, we have the Object Handoff pane, which informs the robot to wait for a detected change in microvibrations in order to socially appropriately release a held object. This is very intuitive for the user, and it truly feels like the robot understands your intent to grab the held object. As can be seen in this demonstration, the user is able to modify the grip strength in order to grasp objects that are irregular, such as this stuffed wolfie. This can also be seen in the socially appropriate release pane, where when in an environment with lots of random data, you can increase the threshold before the hand releases the held object. Now, as we go back to the data graphs pane we analyzed earlier, we can review the data the grasp and handoff objects actions used. Here, we can see the obvious points in the data where an object is being held, along with the points where the hand is empty. Furthermore, by looking at spikes and microvibrations, we can see where the program decided to release the currently held object. As we cycle through the available graphs, we can see changes in every field due to the fingers holding an object as opposed to touching it open air. This can notably be seen in the temperature graph, which has slowly risen ever since it has lost contact with the fluffy animal. As it is not strictly necessary to be in the same location as the PR2 robot, we have also implemented Ross's own RViz program into our program, which allows the user to see physical changes of the robot from remote locations. Once again, thank you for watching our demonstration video. This is the PR2 Robotic Hand and Syntouch Sensor Real-Time Interface Project for the CS 426 2015-2016 University of Nevada, Reno Senior Project class. Thank you.